Hey guys. Sorry. I don't know if you see a black screen or not when I unplug that, but how are y'all doing? I hope you have enjoyed your weekend. Welcome back. It's a full week of school finally. Hopefully, everybody's starting to get back on a normal schedule after the break now. All right, so today we are going to cover exponent word problems. So there's these task cards posted. I'm going to go ahead and work a few of these problems with you, and then I'm going to let you work the rest of them. There's an exit ticket, but it will probably take us 2 days to work on this, okay? We're probably going to work on this today and tomorrow. So don't feel like you have to get all of these problems done today. You're going to have time tomorrow to work on them also. All right, so you can go ahead and open up those. If you go to this activity, then, oh, I haven't added it yet. Dang, I copied it. Sorry, guys, my brain's not working today. You should see a title down here that says Laws of Exponents Task Cards. So click on that. Don't click on this link up here. This isn't going to open it. Click on the link down here. After you finish the assignment, go ahead and click Submit so I can see your work, and then do the attendance check. The exit ticket, not attendance check, exit ticket. All right, so I've got this pulled up on my iPad so I can work it with you here. So I'm going to work a couple of these problems with you. We're going to start with number 1. Let me move this so we can see everything here. All right, problem number 1. So when we're working word problems, especially things like what we're doing today when we're dealing with shapes, the first thing you want to do is draw a picture every time. Draw and label your picture. It's going to make life so much easier. You can see what's happening. You can understand what you're supposed to be doing. So always start with drawing a picture. Okay, so the problem says write an expression. So the difference between an equation and an expression is an equation has an equal sign, which means we're solving. An expression does not have an equal sign, so we don't have to solve. We just have to combine terms, okay? So write an expression which can be used to describe the area, I'm going to highlight this, area in square units of a rectangle that has a length of 5x cubed y to the 5th z squared units and a width of 3x squared y z to the 4th. Okay, so first thing I notice is that we are dealing with a rectangle. So I'm going to go ahead and draw a picture of a rectangle. And then we know that the length is this. So I can say, I'm going to label the top of my rectangle the length. So I'm going to say this is 5x cubed y to the 5th z squared. And my width is 3x squared y z to the 4th. And we want to find out area. Okay, so first, write the formula needed to describe the situation. So how do we find area of a rectangle? Well, area of a rectangle is area equals length times width. And now we want to write and simplify the expression to describe the situation. So area equals length times width. So area equals, my length is 5x cubed y to the 5th z squared. And I'm multiplying that by my width, which is 3x squared y z to the 4th. So now we have a problem like we've been working the past 2 weeks. So the first thing I want to do is multiply. Parentheses means we're multiplying, so I'm going to do 5 times 3 is 15. Then I can do my x's. When I'm multiplying things that have the same base, I add their exponents. So that's going to give me, I guess I should write this in different colors. Let me go ahead and color coordinate this so we can see what's happening here. So x, I do 3 plus 2 is 5. So my exponent is going to be to the 5th power. Then I'm going to have y to the 5th and y. We understand that this exponent is a 1, even though I don't see it. So that means I'm doing 5 plus 1 is 6. So I'm going to have y to the power of 6. And this last piece here, we have z squared and z to the 4. So I'm going to do 2 plus 4 is 6. So I have z to the power of 6. That's my answer. I'm done. Boom. Easy enough. Done. Okay. Then I'm also gonna do problem number 2 with you. I think I'm gonna do 1, 2, and 4. So write an expression. That means there's no equal sign. We don't have to solve. So write an expression which can be used to describe the perimeter in inches of a rectangle that has a length of 2x plus 5 and a width of x plus 9. So I'm dealing with a rectangle again. I'm going to go ahead and draw my rectangle. Its perimeter, I have a length of 2x plus 5. I'm going to go ahead and write it on the other side, 2x plus 5, and a width of x minus 9. X minus 9. Okay, so how do we find perimeter of a rectangle? Well, perimeter is length plus width plus length plus width, which is the same thing as maybe 2L plus 2W. So whichever of these you want to use, I'm fine with. I'm going to go ahead and use the first one, okay? So that means I'm going to do perimeter equals. So my length is 2x plus 5 plus my width is x minus 9 plus my length again is 2x plus 5 plus my width again is x minus 9. We did problems like this at the beginning of the year. Okay, so then I want to go through and I want to combine my like terms. So anything that has an x with it, these are like terms, right? Remember the sign goes with the number behind it. Anything that has x's with it, those are all like terms. Those are, I can't remember who I used at the beginning of the year. Did I use Beyonce and I can't remember. I don't even know. Okay, so I have 2 plus 1 plus 2 plus 1. So 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. So I'm going to have 6x. Then I can add my numbers that don't have x's with it, combine all of these. So in my brain, I'm going to do my positives first. So 5 plus 5 is 10, minus 9 is 1. So 10 minus 9 is 1. 1 minus 9 is going to give me negative 8. Okay, so that means my perimeter equals 6x minus 8. So I know I said expression means we're not going to solve. We're not going to have an equal sign. Here, I'm not solving. I haven't solved to figure out what x is. That's what I mean by solving. We're just going to leave x as in our expression. We're not going to solve to figure out what x is. We're writing it as an expression. And the perimeter can be found using this expression. Okay. All right, number 4. No, hold on. Okay, so number 3 is perimeter. This, add up all your sides. Add up all the sides. Right? Perimeter means add up all the sides, go all the way around it. Number 4 is a triangle. So I'm going to give you the area of a triangle is 1/2 base times height. Perimeter, add all sides. I'm going to help you. There's one specific one I want to work with you. This is area of a rectangle. So we just did that length times width. I guess I'll go ahead and write it. That way you guys have all the formulas. Trapezoid is the one I want to do with you. So we'll come back to 7. 8. Area of a square. I think you guys can handle that formula. Parallelogram has a base. We're doing area. Area of a parallelogram is going to be base times height. Perimeter of a trapezoid, perimeter. It doesn't matter what shape it is. Perimeter is add up all the sides. Area of a parallelogram, again, is area equals base times height. Perimeter, it doesn't matter. Again, here, it doesn't matter what shape it is. Perimeters always add up all the sides. Okay, so even though this is an octagon, add up all the sides. Okay, so I want to do number 7 with you. Let's go back to number 7. Trapezoid. this one, I want to do with you because this area is, this formula is a little bit difficult and you guys haven't really ever dealt with area of a trapezoid before. So write an example which can be used to describe the area of a trapezoid that has bases of x plus 10 and 5x minus 2 and a slant height of x and a height of x squared. Okay, so a trapezoid is this shape right here. So it has 4 sides, but 2 of them have slants, and 2 of them are flat, and one of the flat sides is longer than the other, okay? So we have 2 bases. We have an x plus 10 base, which is the top. The base represents the flat parts, okay? And the bottom, we can use 5x minus 2. The slant height, which means this side over here is x. I think we're going to assume that these slant heights are exactly the same. And then we have a height. So height is we're going to use this little dashed line right here and say this is a right angle. And our height is represented by x squared. Okay? So the area of a trapezoid is 1/2 times base 1 plus base 2 times the height. Okay? So this means area of a trapezoid, we're going to do 1/2. Base 1, it doesn't matter which one we call base 1, which one we call base 2. I'm going to use the top as base 1. So base 1 is x plus 10. And then we're going to add base 2, which is 5x minus 2. And we're going to multiply it by the height. And it's not the slant height. The height, hold on, let me use a different color here so we can connect these. The height is right here, height, okay? So the height is x squared. Okay, so let's take it one step at a time. We need to deal with the things inside the parentheses. So that means in this set of parentheses, I have some things I can combine. I can put some things together here. So I have area equals 1/2. I can put my like terms together. So x plus 5x is 6x. 10 minus 2 is 8. And then we're multiplying that by x squared. So now I'm multiplying 2 things together in those parentheses so I can distribute. I'm going to go ahead and distribute this backwards. Hopefully y'all are okay with that. So this means I have 1/2 6x times x squared. Well, this has an exponent of 1. So I add my exponents. So that means I have 6x cubed plus 8 times x squared is 8x squared. And now I'm multiplying by 1/2. So I'm going to distribute this 1/2 through. So that means 1/2 times 6 is 3x cubed. 1/2 times 8 is 4x squared. So that means the area of this trapezoid can be found by 3x cubed plus 4x squared. Okay? You could have worked this a different way, and that's fine. So you could have gone through and combined your like terms and then maybe distributed your 1/2 and then distributed your x squared, but ultimately you should get to this answer, okay? So play around with that, work those problems how best your brain works, okay? Sometimes your brain doesn't work like my brain. It's okay to take a different way to get to the answer, but just make sure you get to the right answer, okay? So I like to compare it to driving to Walmart. If we all left the high school at the same time and we were going to meet at Walmart, not everybody's going to go the same way, right? We might go down 64, we might go down Evenside, whatever. We can all get to Walmart taking a different path, but we should all end up at Walmart. So I'm okay with you figuring out how to solve these problems and do it the best way that makes sense in your brain, but just make sure you're getting to the same answer that I'm getting to, okay? All right, so I want you to finish this worksheet. So finish these problems. Again, you're going to have today and tomorrow to work on these. If you have any questions, if you need formulas, if you don't understand how to apply the formulas, email me or message me on Remind or on Canvas, and I will make another video for you, okay?